What is going on, guys? Today, we're going to take you into the world of automation, manufacturing and automation, and robotics. This is going to be a pretty cool video. I think people really need some insights to what automation and robotics looks like. And I'm going to kind of just walk you guys through, and we're going to go into this together and do like a step-by-step of some of the different aspects of automation and robotics. And if you have any questions, make sure to put them down in the comments below. Because I know there's going to be a lot of things that I leave out in this video, and I can elaborate in further videos. So just make sure that you leave a comment and whatnot. Let's go ahead and jump into the computer real quick, because it's going to be the easiest way to visualize some things. We can put some things behind me as well, but this is going to be one of the easiest ways. So I'll just take you directly to our website, eliteautomationusa.com, and then we'll come into here, okay? If you want a quote, you can request a quote right here. But in reality, we'll accept the cookies. Give them all the cookies. All right. So, robotics and automation, what is it, right? So as you can see right here, right on our home page, we have a couple of robotic arms. These arms right here are 6-axis arms, and they're made by different brands in this particular instance. This over here is an AMR. And so, for the robotic arms, they come in different style of arms. You can have Delta robots, Scara robots, 6-axis robots, 5-axis robots, Cartesian robots. There's all different types of robots, and then there's different brands. Like as you can see right here, this is a Fanuc, and this right here is a KUKA. You have like Yaskawa and Denso and ABB and Nachi, and there's a ton of brands. I mean, it's not a lot, but there's like maybe like 12 brands, at least 12 like pretty popular brands. There's probably like 24 or 25 or 50 or, you know what I mean? There's probably a decent amount more robots out there. There's nobody knows of them. People haven't really heard of them. And there's also some robots like Cartesian robots that are not necessarily owned by anybody per se. They're just like kind of custom solutions using like Allen Bradley servo drives, which that might be taking it off into the weeds a little bit and taking us down a road that you don't necessarily know of just yet. And so this device over here is an AMR. Okay, what is an AMR? It stands for Autonomous Mobile Robot. It's very, very similar to AGVs. If you don't know what an AGV is, it's an autonomous guided vehicle. But the difference is AGVs utilize some type of tracking method, like some type of track method, I should say, not tracking method. A track method where like it's either a paint strip, it's a magnetic strip, maybe RFID, and it's utilizing some type of physical thing on the ground to locate itself and to make sure that it's staying on path. Whereas an AMR does not utilize that type of technology to stay on path. A lot of AMRs are using what's called a SLAM technology. The SLAM technology basically is using things like laser scanners and LiDARs to generate a map. So it's constantly scanning the area and will generate a map, and then within the user interface, you can program in like, this is an obstacle you need to avoid. This is a safe path to travel. Through this particular path, you need to reduce your speed. In this particular area, you can run at 100% speed, things like that. So you can program and modify its programming to fit the application. AGVs also give you some abilities like that as well. The big differentiator is this doesn't need a track. If it decides if it's going for a path and it decides it wants to take another route, it can hurry up, turn around, and go a different way. It can abandon a mission and choose a new mission at any point in time. And also, these are being commanded by fleet systems, which newer AGVs do the same as well. They have fleet systems as well. But whenever it's able to leave its track or leave its designated path and just go off into another direction, that can be extremely powerful, because maybe sometimes in a manufacturing process, something comes up that's a much hotter item, like your most highest production line gets backed up, and you need somebody to come relieve material off of that line right now so you can keep moving forward. Whereas an AMR is able to accommodate for that, whereas an AGV may be a little bit more complex, or may not have as many opportunities to be able to shift its path and go a different direction. Okay, turnkey system integration. I'm gonna just kind of take you a little bit through our website, like what these things mean, right? Because like I think that's gonna be a good kind of path to travel down. Talking about paths, right? Turnkey integration, turnkey system integration. Essentially, what that means is that we provide a product that is complete and ready to use. So for us, it's a lot of robotic systems, a lot of robotic applications. We'll say like a palletizing application, for an example. And the turnkey part of that, right, is the fact that we build any type of structures that need to go into the system, all the programming to handle different box sizes, the end-of-arm tooling to pick up the boxes, the selection of the robot size, the electrical engineering and any mechanical engineering that's involved in that, the layout of the cell and the fencing, and then the installation, right? So the installation and the wiring, all those things are covered under our company. You know, our team members will essentially, from the concept to the install of the project, will take ownership and complete that project. That's what turnkey system integration means. Specialization. So for us as a company, we're very specialized in robotic welding now, at least as a marketing standpoint. We still do a bunch of material handling applications, and we're definitely not shying away from material handling, but as being known in the industry, we're looking to be known as a robotic welding company. It's just a business model that we've kind of ran into. It's our engineers are very strong in welding, and for us as a business, and for me personally, like we just made that decision. Like this is the road we're going to go down. We're going to start doing a lot more robotic welding and niche down what services we're actually offering. Other areas of focus, as you can see right here, palletizing, AMR deployment, mechanical designing and fabrication, material handling. So we're also doing a lot of mechanical engineering and CNC machining of custom components. Anything that's like small and highly detailed, high precision, we're able to be very cost effective and very competitive in speed. But moving forward, so who is Lead Automation? You can watch that video if you want to watch that video at some point. Here's where we're located at. So we're located in Evansville, Indiana. This video is not really about us. So as you can see here, here's a strip of like some of the different things that we've had going on throughout the past few years. We've been attending a ton of events. Attend events, right? Industry-specific events. If you're wanting to get industrial automation, go to these events and explore what they're like. Any of these events that you can go to, get you an Airbnb, make it more affordable. Maybe if you can go with some other college students, then maybe that will make it more cost effective for you guys. But I highly suggest that you go to as many events as you can, because there's so much learning that can happen. There's so much networking and like just being able to talk with people and say, hey, can you educate me on this? Right? You can go up to booths and just basically just get a college course, right? In the matter of a few weeks, just talking to highly educated people and being able to visually see things and visually see systems and different types of systems and different brands, and it's a great place to get a full exposure to the market, which is like how I'm trying to make this video, right? Like this is why this is just a very free-flowing video. We're just kind of walking through our website, because if you don't really grasp what the industry looks like, it's hard to make an educated decision on what direction you'd like to go in your career, and then you may make a decision in a direction, but maybe it's not the best decision and direction to go. So being educated helps you make better educated decisions, right? Let's see, RFQ. Just kind of taking you through their website a little bit more. Okay, blah, blah, blah. You can see here we have some robotic welders in the background. These are your scour robots. You got 3 robots doing one weld operation. Essentially, we're putting 3 robots to this one operation to increase cycle time. So instead of having one robot having to do all these different passes, you have 3 robots that can be all welding a different pass at a separate time, or at the same time, I should say. Okay, let's go. capabilities page. Here's those same 3 robots, robotic welding, then fixture design and manufacturing. So all these small components, a little bit hard to see probably in this video that you're seeing here, but these are all like very finely detailed items. AMR logistics, material handling, remote support of like PLCs and robots. So PLC and robot programming is a huge part of this industry, huge part of what you can do as a career. I highly suggest going down the road of programming because it's going to offer so many opportunities, and you can't go wrong with it, right? Like, you can get a job anywhere if you know controls engineering. Whereas some of these other disciplines, like electrical engineering, I find that very hard to, like, need a lot of it, and also too, like, it just isn't very exciting, especially over a long period of time. All the engineering prints end up being very similar, at least for like us. Like, we have a very good standard, so like we change very few things on our electrical engineering prints, application to application. And a lot of things that we do, we use Ethernet based communication, which is another topic, but a lot of these devices in the industry are getting connected through Ethernet, which means they are needing a lot less wiring, which means a lot less electrical engineering. Okay, welding capabilities. Let's just run through some things. And there's stuff that we have available that's not on our website. So here we have a positioner, a robotic arm to perform the welding, and then this right here would also have like your fixturing to hold your part that you need to weld. Hopefully these things are like very insightful, and let me know if like there's a different style of these videos you'd like for me to do. As you can tell, I'm not really trying to present what we do as a company per se. I'm just taking you through the things that we do to kind of help illustrate and give a good demonstration of some of the things that we are directly working with. So as mentioned before, like cell layout, this is part of what we do. We do all this layouting. This is fairly simple, like robotic weld applications are pretty easy. There's not a bunch of layouting that goes on within them. The biggest thing as far as that goes is like your robot arm that you select, and then like reach, right? And also I guess your positioner, it needs to be the right size positioner for whatever it is that you are planning on welding, and if you want to weld multiple components at one time or just one single component at one time. Those are all things that go into like the engineering process where this may change. Maybe the positioner needs to be different size, or we have to use a different spanner, and so we design and fabricate that spanner. And then as you can see here, you have like the fencing dimensions. So like those things will change somewhat, but like a lot of the things we'll try to keep it the same size. So like even our fencing may be the same, like fencing and the same interlocks that we use every time, and try to keep that standardized. So that way, whenever we change something and make something a custom application, it's only 10-20% of the application that needs to be modified. That's just a close-up of a positioner with actually has some fencing in there in that positioner. Doop. That was some trials there, actually, of some other fence stuff. Yeah, there it is right there, actually. And all these things are accessible on our website. I'll let this one play real quick because it's a pretty good one. Okay, maybe. Oh, I can't. You got to down. By the way, if you want to click on any of these videos, you have to download the PDF up here at the top. Download Robotics Welding PDF, and then you can watch the videos. They're clickable, but you can't tell from the website. Here's an example of a welding application where the robot is on a linear rail, and it's so that you can use a smaller robot to span a very long distance, and also sometimes like there's not even a robot big enough to handle like this span of distance, or if you did, it would be a massive $150,000 robot whenever you could do this with a $50,000 robot and a $50,000 rail and do it in 2/3 of the cost, and it being the actual better solution for the project. Got some more positioners here. Boom, boom, boom. Okay. Mechanical engineering and machining. So if you're looking to become a mechanical engineer, these things right here might be super valuable for you. Let me see how long of record time we've been doing. Oh, shoot. 18 minutes. Okay. Okay, back. Okay, so robot tooling design, manufacturing projects. So this right here is a leak detection unit for some casting. Basically, we apply air and we test some circuits inside of a aluminum casting, which you may not know what a casting is if you're just now getting into the industry. Here's what the device looks like, or the system, however you want to call it, looks like in the real world. Doop, doop, doop. Here you can see some grippers for die casting. So we do quite a bit of work in the die casting field for like different customized grippers and deburr trim grippers and leak detection units. So yeah, I guess to dive a little bit more into like somebody would be doing mechanical engineering. So if you look, I don't know if I can zoom in enough on this, but as you can see, there's like details in here, right? And these details are engineered to fit into this casting. And as you can see, all these different details in here all match up perfectly and like within like 0.1 mm, I think. 0.1 millimeters tolerance. They have to be extremely tight because if not, then essentially they don't do their job, right? They don't grip appropriately, or like you run into collisions and things like that. So you can see right here where like it grips it in that particular area. I'm also not a mechanical designer, so here's another area where you can see it gripping the runner. Boom, boom, boom. Take it to another one. So zoom in on this one. It's kind of hard to see the details. You get some better pictures of the details themselves and just show like how detailed they are, because I mean they're like pretty wild on the level of detail. Yeah, guys, we're the good detail pictures, man. All right. So yeah, I guess that's something we do need to call out. See, that's why I do these videos, really. I'm just finding gaps. No, I'm just kidding. So this would be something more of a trim deburr gripper. You can see this gripper's like quite a bit different, and we got to grip the part in a different way. Because one of them we're taking it out of a die cast machine. Another one this one here we're trimming the part for like flash and whatnot. And just deburring some of the holes, which is also kind of a flash type situation. And you can see here, just another custom tooling for injection molding. We did some over molding with these products, and essentially had to pick up a bearing, put the bearing inside the injection molding machine, and then we had to injection mold the part, take the part out, load that part into another injection molding machine, and then it molded over it again, and then kicked it off into a conveyor. So with this, we had a few different technologies. As you can see, we did quite a bit of mechanical engineering, or I guess a little bit of mechanical engineering on this. Decent amount, though, actually. For all the constraints that we had, this tooling was, I don't want to say like extremely complex, but we had a lot of constraints to deal with because we had to get in between the tie bars of the injection molding machine. We had to be able to spin this thing inside the injection molding machine with a very tight space. Then they came back and told us that the mold floats. So like the part that moves, if you know injection molding machines, right? There's one of the surfaces moves, and they said that, well, it stops within about 1 inch every time. So like it floated around, like whenever it opened, it would be within 1 inch from where it was supposed to be, somewhere within 1 inch. They could, but when we're replacing with the robot, you can't have that. So one of the things that we did with this particular tooling is we put a laser on it, so that way we could take a laser measurement of how far the mold face was away exactly, and then that was able to give us the position that we needed. Also, we had like Cognex vision on here, which we utilized to detect that the bearing was actually placed into position, and basically did a verification check that it was in the proper position as well. So not only is it present, but is it within tolerance of where it needs to be placed at, so that way when the injection mold closes, it doesn't close up on the bearing and screw up the injection molding machine. Here are some examples of some conveyors. These particular conveyors, so we design different custom conveyors. Sometimes we purchase conveyors. That's one thing about a systems integrator. It kind of really depends on what your application is, and if it makes sense for you to outsource the work or to buy something that's just off the shelf. So like for us, generally if we're outsourcing something, it's because you can buy it off a shelf, right? If somebody already has a conveyor that's made that like fits the need that we have, then we generally will just buy it, right? We don't necessarily make conveyors that you can just buy off a shelf and somebody already has them pre-engineered and ready to go. Boom, boom, boom. Robotic palletizing. Let's go. So this is kind of just a simple palletizing operation. Here's, the robotic cell. There's not really, I don't know what really there is to get into this one too much. These are done with, you can see palletizing robots. So palletizing robots are generally 4-axis or 5? I think they're 4-axis. 1, 2, 3, 4. I don't want to get this wrong for you guys. 1, 2, 3. I think it's 4. So you have one at the joint, the base down here. You have one right here. So the joint 1, axis 2, axis 3. Then you have axis 4 for rotate. You don't have yaw pitch row, so that's why you don't have. That's why it's only 4-axis, right? Well, I want to say it's 5. Whatever, right? Just I'm having like a brain fart at the moment. So just go with me on this one, okay? And so the reason why palletizing robots don't have the WPR, what yaw pitch roll, and that's how you refer to it in robotics, right? The reason for that is because whenever you're placing a box, like you don't need to have yaw pitch roll, because like if you're stacking a box, here's one box, you're just gonna stack another box on top of it. You're never gonna stack a box like this. Like why would you ever stack a box like that? So you don't have a need for WPR. Also, the robots are a little bit cheaper. Downside is sometimes the lead times can be higher because people are getting them because they're cheaper for palletizing operations. Also, I think they're designed to last a little bit longer in palletizing operations, especially if you are utilizing a robot that is close to maxing out its payload. That's something to keep in mind whenever people are like selecting robots. Like to select robots that are, if they are very close to the payload limit or its speed limit, that robot's life capacity is going to be much less than what it normally would be. So just keep that in mind if you're ever selecting a robot. Okay, as you can see here, we're using an AMR to deliver pallets and also to receive. So as you can see here, we have a palletizing robot essentially palletizing these pallets. Notice there's 2 pallets right here. And the reason for that is so this robot can stack and fill this pallet. This AMR can come pick up this pallet here, this full pallet, and this robot can immediately start stacking on this other pallet here. Now, while that full pallet is rolling out to the AMR, or the robot's waiting for that AMR to come pick that pallet, the robot can continue its process without moving, because a lot of automation processes, a lot of manufacturing processes, you don't want the operation to stop for anything, right? So one of the things you do to combat that is to have 2 locations to place to. which is what we've accomplished here. And then it's also being tended by an AMR. So ideal situation is, or the engineered solution would be, that these boxes, as this one's filling up this next one, this AMR would have this one out, and there would be another AMR ready to come receive the pallet, the next full pallet, right? So it's like a continuous operation. As soon as the AMR rolls up, it's ready. It just got full, and it's sending it off to the AMR to go store it in the warehouse or wherever the next operation is. Maybe it goes immediately on a truck for shipment. And so things like this can be extremely powerful for manufacturers to like deliver. Like if they have to deliver these like a really far distance, maybe where they load their trucks is like, I don't know, 3 football fields away, right? Then you, instead of having a fork truck driver that needs to run back and forth all day who doesn't stop, you could have, this is one solution to help cut cost and make things like logistically more feasible, is have that same fork truck driver in the back where the loading of the truck is, and maybe it's an operation where it needed like 3 or 4 fork truck drivers to maintain this operation. Well, one thing you could do is have one fork truck driver, not have the other 3 fork truck drivers, and have these AMRs go and do the pickup and drop off, pickup and drop off, pickup and drop off. And now the AMR is performing that operation. It's the one traveling the whole entire football field and whatnot. So this provides a lot of value for the manufacturer, because now obviously they have 3 less fork truck drivers they got to employ. And if you don't know already, fork truck drivers is one of the gaps in the industry. So we've talked a little bit about AMRs. We've talked a little bit about the palletizing, the logistics side of things. AMRs are super powerful for being able to do things like this. And, one reason why we push AMRs is because it's a new technology. You didn't really have this capability to have this flexibility. And not only can this same AMR tend this robotic cell here, but it can also tend 5 other robotic cells. So if you needed to buy 10 of these AMRs to keep up with your systems, the cost can be divided across all the different robotic cells that it needs to service. And for a perfect example is like if it had 4 fork truck drivers and you consolidate it down to 1 fork truck driver, your ROI is based on 3 fork truck driver salary for 3 shifts a day, 5 days a week. That number adds up fairly quickly. I mean, you immediately have like a $150,000 1-year ROI or $300,000 2-year ROI. This is some rough numbers off the top of the head, but this a quick, easy way to kind of calculate that. Some bag palletizing. This is also a video too. It's clickable. Boom, boom, boom. This is also clickable. His box palletizing. So this one's done by layer formation. This is pretty cool. So the layers are built up at the top side here. And all the stacking and configuration is done. And this is known as a formator. So it'll formate the layers, and then the robot essentially picks up the entire layer at one time. So that's another method about going about doing palletizing. And you'll see it in a lot of like box type of operations. Also a video. This one's of palletizing some water bottles. Boom, boom, boom. Bin picking is another really big one. The reason why bin picking is so popular or is so important is because the technology is somewhat new. This is also a video. I wish I could play some of these videos. I could download all these and play the videos, but you guys can go to our website and download them if you want. But basically, this thing's just picking back and forth, and it's using a bin picking vision system to locate all the parts. And the locating of these parts and being able to do this bin picking operation is new in the sense of it's been around for 5 years or so, but maybe even longer than that. But it's just now really became where it's like reliable over the past like 3 years, and then over even like the past couple years where it's getting more and more reliable, right? People have been working on the system and developing it to be better and better and better. and it's finally to a reliable state. And part of the reason why it's so important is bin picking was an operation that couldn't be done before in the past, right? And a lot of manufacturers, as soon as something comes off the end of their line, this is the way that they're packaging their stuff. They're just throwing it inside of a bin, right? And whenever you throw something inside of a bin like this, you make it impossible to automate. So there's one or two things that need to happen, right? You need a really good bin picking vision system, or you have to nest all your parts. So which means if you nest all your parts, which means to stack them in a very neat and clean way, right? In a very known and defined way. In order to do that, you have to make custom racks. You have to make custom bins or custom inserts where, like if you notice, if you buy a brand new phone, your phone's not just sitting in the box, right? Like it's nested into the carrier thing that it comes in, right? This thing won't stay over there. So being that it's not nested, or being that your phone is like nested, that's what nesting is, right? And so like if you had 10 phones, they would all be nested in the same type of thing, and that's what nesting is, and you need that type of feature. So you're like, okay, well, why would you not just nest the parts? Well, the next issue is the logistical side of things. One, you have to have all those made. Somebody has to make those inserts or those specialty racks or specialty bins, and that costs tens of thousands of dollars. It could be hundreds of thousands of dollars, depending on how big of an operation a company is running. And then the next issue to that is the logistical side of things. With if these components are going from the end of a line to their customer's facility, now they have to worry about shipping the parts with these inserts and how do they get their inserts back? How do they receive back their inserts or their specialty bins, right? So now all the empty containers need to be brought back to the manufacturing facility, which can become very, very expensive at, multi-thousands of dollars per shipment. Whenever a company has 100 trucks in a day, now you're spending $100,000 in a day. I'm just giving random numbers, by the way. They're spending $100,000 in a day, $1 million in a day, just delivering empty bins back to a facility. I think that's the way we need to go humanity-wise, and because as we get more automated, we need things to be automatable, right? And automation is the way, it's the future, and really I just think it's better for humanity, right? Like as humans, I'm not saying we should do less, but like we need to focus on more important things like family, and focus on, things like work-life balance, and focusing towards happiness. Like, there's so many people that are unhappy in this world today, and it's like, why? Like, we have electricity, we have heat, we have water. Like, happiness should be of abundance at this point. We really don't even need, as a human society, we really don't even need any more technology. We just need to utilize the technology we have now to make our lives better. And what does that mean? That doesn't mean just more ROI for a manufacturing company. It means making it so that, our daily lives are better, and making it so that either there's universal basic income or some type of, the thing is that I don't want to go into universal basic income, but we need some type of income. Like, we're underpaid. Like, individual humans, in my opinion, are underpaid. Like, why do people have to work 60-hour weeks, 80-hour weeks, and then they're still struggling financially? Like, especially anybody who's working over 40 hours a week. That person should not have any struggle financially. They should be able to go buy a boat, go buy a new truck, go buy a new car, go buy all these new things, right? Not any day and every day of the week, but like have the capability of doing so. That's a side topic, though. It's just part of like one of my passion things and one of the missions of the company. Kind of taking you guys through the same thing. Here's another version of bin picking in a smaller type of bin. And basically being able to identify these deodorants. These are all videos, so if you want to go check it out and download the brochure, feel free to do so. Boom, boom, boom. Guys, this is becoming an extremely long video. Going into AMR Logistics, this is just taking you through our website. right? This is just taking you through the Elite Automation website. We haven't even dug into like anybody else's website or any other things outside of our company, and I could keep diving deeper into some of the things we're seeing here. Here is all the different brands. So this kind of gives you, not all the different brands, there's actually other brands out there as well, but here's a taste of the brands that are in the industry, in the market for AMR technologies. Some of these are companies like Waypoint is actually bought by Locus, and you'll see a lot of that probably in the future. Like, this is a new technology and everybody wants all the market share. Mir is one of the most popular brands of an AMR. By far, they've been crushing it in their marketing and everything that they're doing. So these things are in logistic, agriculture, manufacturing, and healthcare. We're going to see these things utilized in some very creative spaces. You'll start to see them at restaurants. You'll start to see them in hospitals like this. In the manufacturing, you'll see, they're already there, but you're going to see even more creative use cases like this one you see here with a universal robot, a collaborative robot on top of it. So that way the robot is able to move around and do things. You guys want to read through any of that stuff, feel free to read through it. Here's a tugger. This one's got follow me feature, which is extremely cool. You basically press a button that says follow me. It'll identify you, and then it'll just follow you, right? Which is a pretty cool feature. So like if it was carrying a heavy payload, you just press a button and just start walking, and then it'll follow you, and yeah, really cool. Here's another, just a small use case of an AMR or a Mir. Maybe I'll do another one where we go through some of these videos and what they do. Here's one that we deployed with the top module. So basically this part conveys onto this AMR. We take this to another operator station, and that way they can essentially have one operator tend two presses. This just kind of gives some dimensions and whatnot of, this is the Mir, I think 1250 right here. It's not really listed. Load surface. Yeah, this is the Mir 12 or 1350, I believe. 1350, sorry. So it can lift 13. It can move 1350 kg, which is like 2,700 pounds. It's quite massive. 1350. There you go. Runtime, dimensions, tells you all the things right there. Max speed, 1.2 meters per second. Battery is something that we get questioned on quite a bit. Like, how long will the battery last? Communication protocols, you can handle Modbus, so you can communicate REST API. A lot of people are not doing this yet, but like, you can communicate with this through like Modbus over Ethernet IP, and then and be able to command this things like through a PLC, and then also like stuff like the AMRs, like the programming language is not the best, and it's not very powerful, and it's not very, how do you call it? It's very sequential. So like, since the programming is very like step by step by step, it doesn't really have the ability to like jump out and do stuff. I mean, you can, but like it's like just not very easy. The AMRs have like obstacle avoidance, so you can either program them to have a very strict path, or as you can see, it has a obstacle in the way, and it's able to go around the obstacle. This is just some pictures from one of our deployments. Another picture example of the palletizing cell. Same thing. And there we go. I'm about to have to wrap this up, guys. What time we got going on here? Oh, shoot. 12 minutes. Okay, this is a long video. This might be a two-parter. Okay, going into simulation. Simulation is something that I'm actually pretty excited about. We do quite a bit of simulation work and remote programming and things like that. And so simulation is basically a virtual version of the robot. So, material handling, spot welding, riveting, arc welding, seaming and gluing, hemming, projection welding, robot OLP. Okay. So basically, a lot of these are actually like BIW lines and weld lines and stuff like that. So I'm just kind of brush through this real quick because I'm not our simulation guy. But here's a MIG welding line. And also all of this is like, if I could zoom in, the detail's not extremely good in here, but these are like all like robotic cells that we've helped do, like we've done simulation work on and help design layouting and things like that, and then doing like analysis of like cycle times and robot reach and all those good things. So like a lot of these big systems like this, like those, there's a lot of analyzation that goes on. So you can see we have different things here, different robotic cells, weld cells actually. So I'm just gonna brush through these real quick. These are pretty cool, but I don't have a lot of personal knowledge on these particular projects. I didn't handle them. Some projects I have a high amount of involvement with. Some other projects I don't have a high involvement with. Another welding. Some of these are videos too. These are videos. Hey, look. There's our building. No. Oh. Boom. There you go. All right. Good deal. Remote support. So the remote support, this is kind of just going through like too much of our like what we do as a company, but for the remote support, basically we're able to like VPN into systems. We have like a really good structure as far as like how we store things. Like we have very good procedures on that, like being able to log in and access devices remotely and be able to troubleshoot. Utilizing different VPNs. So these are VPNs here, which give us the ability to portal into the devices that are on site, so that way we can log in and troubleshoot code. We're also install like different industrial PCs for the applications where we can't just remote in via the VPN. Sometimes we have to like TeamViewer in or utilize one of the other remote access tools for PCs. Because like some devices are like USB devices. That's like one of the primary reasons where we use it. Or if ever we have like PC-based code for anything, then we have to have a industrial PC on there as well. Boom, boom, boom. All right, so that takes you through majority of our website. Industrial automation careers. Well, I'll have to shoot some more videos. Let me know down in the comments below like what you want video-wise, some things that you'd like to learn. If you'd like to join our team, you can subscribe. The manufacturing come up, check it out, because it's people's story from our industry and how they got to where they're at in their career. And we've had very successful individuals on here, like CEOs of $1 billion company, like very successful entrepreneurs and things like that. So these people are just walking us through their story and just telling us how they got to where they're at and the different things that they did to accomplish that. You actually go onto our website and find the podcast. So like our podcast is on YouTube and all the other podcast platforms. I think these link to all the different platforms and whatnot. Also, social media, if you're looking for us on any social media platform, you can find us down here. Me personally, I'm on Facebook a lot. I'm on LinkedIn a lot. Facebook's more personal. LinkedIn is more business professional. And I'm there a lot, though. I'm there on LinkedIn more than I am on Facebook, but Facebook is a little bit more behind the scenes. So, yeah, we have like over 25 podcast episodes launched. If there's any other information that you'd like to know, whether it be about our company or whether it be just about industrial automation as a whole, I think going through the things that we went through today gave you it wasn't very brief, but it gave you some insights to the industry and some of the things that are going on in the industry, and just a small insight to like what is going on inside of an industrial automation company. And I'm happy to make many more of these videos like this and walk you guys through any particular topics on like robotics and things like that. The things that I do try to avoid, to be honest, is like I can't it's hard for me to do like tutorial style videos. One, because really the main thing is it's time consuming, right? If I want to shoot a 30-minute video, I got to sit down for 2 to 3 hours to shoot a 20-minute video, and then just don't really have time for those type of things. Whereas this, like here, I can like sit down and basically turn on the camera and just talk about the things that I know, the things that I've learned, and just share my experience and expertise. So put it in the comments below if there's anything in particular you like about this video, and things that you'd maybe like for me to dive deeper on. Any of those feedbacks are extremely helpful, and we look forward to seeing you in the next one.